Alright guys, today we want to look at sketching linear relations using the intercepts method. Okay, so to do this we need to be able to find x and y axes intercepts using algebra, and we want to know by the end of the lesson when it's best to use the intercepts method and when it's best to use the gradient intercept method. Okay, and you also want to be able to sketch using both methods. Okay, so thought we'd kick things off just by this question here, which asks, decide if the point -1, 5 is on the line with given equations. Okay, so keep in mind that this is a coordinate pair, okay, x, y. Okay, so therefore, I'm just going to do example A. Okay, so now we have the equation y equals -3x plus 2. Now, if we just substitute this x value in, okay, to this equation, on our right-hand side, we're going to have -3, okay, so yeah. Then we're going to substitute x equals -1 into this, so times -1 plus 2, okay, and we're going to get -3 times -1 is 3, plus 2, which is equal to 5, which is equal to our y value up here. Okay, so which is equal to y. Okay, so therefore -1, 5 is on the line y equals -3x plus 2. Okay. So yeah, any time that the equation holds true by substituting the values in, it will work. If we looked at this second one here, okay, if I substitute y equals 5, okay, into that equation, I get 5 on my left-hand side, and then equals, okay, then I've got -2 times x of -1, so times -1, okay, so our x value here, oh, -1, okay, because we've got a -1 here. So we get 2 minus 1 on this side, which is equal to 1, which does not equal 5. Okay, so therefore not on the line. Okay, so that's that type of question. Substitute any point in for x and y to determine if it's on the line or not. Okay. So just for a recap from yesterday, okay, so we have our gradient intercept form of an equation here. Okay, so y equals mx plus c. Okay, so m is the gradient, c is the y-intercept. Remember, zero gradient, undefined gradient. Okay, so the horizontal line, zero gradient, vertical line, undefined. Okay, negative gradient, nice negative, puff, puff, positive. That's right. Remember slope curve, okay? Now, today, we're looking at using the intercepts method, okay? So, it's important here to know that the intercepts only occur at one point for linear graphs, and it's where they cross the x and y axes, okay? So, the y-intercept is the y value where x equals 0, okay? And the x-intercept is the value where y equals 0, okay? So, that's important here. So everything on this line, the x-axis, has y equals 0, and everything on the y-axis has x equals 0. Okay, so we're going to use that information today. Alright, so y equals 2x plus 5. Okay, now we want to be able to sketch. So, using the gradient intercept method, okay, we know that our gradient is 2, okay, which means that there's a rise of 2 and a run of 1. Okay, so it's a positive linear graph. Okay, our y-intercept is plus 5. Okay, so quick sketch of this. Oh, oops. Y-intercept of 5 up to 0, 5, sorry, up to 7 cross 1. So this point here is 1, 7. Okay, and then you use a ruler. I'm just going to draw like that. It's our x-axis and our y-axis. Okay, so that's the graph of y equals 2x plus 5 using the gradient intercept method. Now, the second method is the intercepts method. Okay, so we're going to find both axes intercepts. Okay, so recall that just change pen here, the y-intercept is when x equals 0. Okay, therefore, if we substitute x equals 0 into the equation, we get y equals 2 times 0 plus 5, which is equal to 5. Okay, but we already knew that. Okay. And then our x-intercept occurs when y equals 0. Okay, so we substitute y equals 0 into the equation, which gives us 0 equals 2x plus 5, or 2x plus 5 equals 0, 2x equals minus 5, x equals minus 5 over 2. Okay, I'm just going to scroll down a bit. Okay, so now our information tells us that our y-intercept is 5 and our x-intercept is minus 5 over 2, or okay, so x-intercept, y-intercept. Right, then sketching this graph. Okay, I'm just running out of space a bit here, but our Cartesian plane, draw that. Okay, I'm just going to draw a little graph here. Here. Okay, so we know that all we have to do is label our coordinates. And this one was minus 5 over 2, 0. Okay, and then draw a straight line. Try to get a straight line. Not too bad. Okay, and there we have it. Okay, so which method was better? Okay, I think this one, because we're already told it's in the gradient intercept form, so it's easy to do. This one, a little bit of algebra, especially finding the x-intercept, so potentially a bit better to use the gradient intercept method. Okay, now we're going to look at when the equation is in this form. So yesterday we looked at rearranging this into gradient intercept form. Okay, so which required a bit of algebra, but not too bad, but a little bit. Okay, here I just want to use the intercepts method just so that we can practice that and show that it might be a better method. Okay, so here we're going to start off by finding, why is that not happening? Okay, I was going to use a blue pen, but something's wrong with my pen. Alright, so x plus 3y equals 4. Okay, so let's just start with the y-intercept. Okay, so we know that that happens when x equals 0. So when x equals 0, 3y equals 4, y equals 4 over 3. Okay, so that's our y-intercept. Alright. And for our x-intercept, occurs when y equals 0. Okay, so substituting that into here, we get x equals 4. Okay, so that there was pretty straightforward. Okay, so now sketching this, okay, because it's a straight line, all we need is our 2 points again, and this one's a positive y-intercept. This one's also a positive x-intercept, so we're going to cross here, and we're going to cross here somewhere. So we can draw a straight line anywhere, okay, as long as it cuts through the axes, okay. This is our x-axis, this is our y-axis. Now, all we need to do is label these points. So this one is our y-intercept, which is 0, x is 0, y is 4 over 3. And this one here is our x-intercept, which is 4, 0. Okay, so that's it. So as you can see, by using that method, it eliminates the need to have to rearrange into this format. Okay, and then that'll, because it's a straight line, our 2 axes intercepts act as our 2 points that we need, and therefore it's an easier method. Okay, so here you can make your own mind up, but if it's in y equals mx plus c form, okay, we know we know what c equals, and then we can sketch from there. Okay, in this format, okay, a simple substitution of x equals 0 gives us the y-intercept, y equals 0 gives us the x-intercept, okay, that will give us our 2 points, okay, that's all we need. So, yeah, practice both methods. Need to be able to rearrange always, because that will help us find the gradient of any line, but if it doesn't ask for that, it's asked for a quick sketch, then you might just find the axes intercepts. Okay. Now, last thing I want to look at is the special lines. Okay, so these ones occur when there's only one axis intercept. Okay, so for example, y equals mx. So say if that was a graph y equals minus 2x, okay, it's because we have our c equals 0. Okay, so this type of line here has an intercept that goes through the origin. Okay, these horizontal lines here, they cross through at a point, so you could have y equals 4, y equals minus 3, okay, so then we call them y equals c, so that's for horizontal lines. Okay, so for every x value, y is 4. Okay, for vertical lines, for every y value, x will equal whatever value it is, so in this case b. Okay, so it crosses through at b0, so it could be x equals 3, x equals 5. These are actually not points, they are vertical lines. Okay, so that's going to be important for your lesson today. All right. So your textbook questions you can complete today for practice are here. Okay, those ones are sketching using intercepts method. These ones are a recap of yesterday and today's lesson. So good. All right, thanks guys.